Hello, I'm Bineta Mondol, and today I'm going to present advancement of resin and rock bolt for underground mine comprehensive review. This research is done for engineering research method subject. My research objective are examining the resin and rock bolt considering variety of factor and their advancement in underground mine, and identifying technologies, material, methods that are commonly used in anchoring. Here we'll consider the geological condition and rock type and identify the research gap. My research question is, how have the advancement in resin anchored rock bolt transformed underground mine system? At first, we need to know what is a rock bolt. A rock bolt is a long anchor bolt which is used for support in underground or in any tunnel. We can see a cross-section picture, and then we can see the actual steel rod or rock bolt, and in the third picture we can see how it is installed in a rock wall or in an underground mine. For the experiment, we did quite a lot literature review for understanding the multitude of experiments that aim to improve the understanding of resin anchored rock bolt. These experiments employ research design in a specific goals, and the experiments include laboratory tests such as pull out, compression, shear test. In addition, field observation provided insight into the efficiency of real world scenarios. Here we can see a picture of a rock bolt, and around that the layer is of resin. Then we are going to the design component. The design component consists of two primary components: laboratory testing and field observation. In the laboratory testing, we will conduct tests to evaluate mechanical characteristics including bonding strength, load bearing capacity, and more. Various factors influence the performance like type of resin, curing time, borehole preparation, environmental condition, and that need to be considered. And for laboratory test, numerous samples should be tested because without this we cannot get reliable result. In the field, we will focus on the practical efficiency, and the field test will be conducted in mine visit. Then we can see a bolt anchoring rectifying devices. These are the simulated picture of the device, and then this is a picture of a rock bolt inside a rock. The dark gray portion is for the rock, the white part is representing bolt, the sky blue thin line represents resin, and the yellow part resin filling body. Here we see the load bearing capacity by elastic state, plastic state, or both elastic and plastic state. Then comes the variable and factor that affect the experiment. The variables are type of resin, curing time, borehole preparation, experimental condition, and many more. It will depend on the type of resin what we are using. Depending on that, the curing time will be different. Like for epoxy resin, it's 30 minutes in laboratory testing, and methyl methacrylate, it's 1 hour in field observation. And mostly in laboratory testing, we do manual drilling for the test. In field observation, there will be always mechanical drilling. Not always, most of the time it will be mechanical drilling. And the geological condition would be simulated in laboratory test. In field observation, it will be vary depending on the mine type. We used mixed method approach that will combine the strength both laboratory testing or field observation. This approach allows to conduct evaluation that will capture real world application in the field of the mine. By triangulating data from multiple sources, we aim to achieve a comprehensive understanding of the advancement in resin anchored rock bolt. Now we will find the strength or advantage of the research. The mixed method research enables a thorough investigation of the subject. For that, we understand the structural integrity and load bearing capacity better, and use of a smart sensor achieve real-time monitoring. By combining laboratory and field observation, we provide in-depth explanation of how resin anchored rock bolt work under controlled or real-world conditions. And this triangulation of data source enhance the credibility of research finding. We have few limitations also, Access to active mines for field observation may be limited. Field observation may have potential limitation, including variance due to uncontrollable factor. Cost consideration also should be kept in mind, because for laboratory tests we need to buy samples or resin or other things, and for field research we need to go to the mine visit, which will include some cost. In conclusion, research design use mixed method approach, investigate advancement in resin and core rock. By combining both strength of laboratory and field observation, we aim to provide profound insight into the anchoring system efficiency, adaptability across various geological setting and rock type. Thank you.